Hello, welcome to the AM podcast. I'm your host, Yijia. In today's episode, we are so honored to welcome Woosuk Kwon, who is a creator of vLLM and currently the CTO of Inferact, an AI startup that focuses on AI inference server.
We got more users from this simple UX than vLLM's performance, very honestly. vLLM is actually honestly not the very first inference engine that can run LLMs. There are actually a few preceders like NVIDIA faster transformer. Unfortunately, it's definitely difficult to set up. As a part of the project, I talked to a lot of customers, the users, and also potential users as well. Actually, that helped me shape my research taste and project taste early on in my PhD.
The boundary of inference and training suddenly blur. Maybe there's no boundary. This future, as you mentioned, I think it shows inference or this AI infra really has a lot of opportunities.
Open source is still just a library. And there's a fundamental limitation of what a library can do.
Hello, welcome to the AM podcast. I'm your host, Yijia. In today's episode, we are so honored to welcome Woosuk Kwon, who is a creator of vLLM and currently the CTO of Inferact, an AI startup that focuses on AI inference server. I first met Woosuk when we were working at the same company last year, and I think Woosuk is definitely one of the few people in the world who are at the very frontier of AI infra. Last year, I remembered we have some really nice conversations about how human-centered applications and AI infra interact. So I'm so glad to be able to continue some of our conversations today. Also, in today's episode, Woosuk shared some of the human-centered design in vLLM that helped it stand out in the space. Hopefully, our conversation would offer you some new perspectives. Hi, Woosuk. Thank you so much for accepting our invitation to come to the AM podcast today. First, I want to say huge congratulations for the successful launch of the new company, Inferact. Where are you guys currently located?
First of all, thanks for having me here today. I'm very honored to appear in this podcast. And yeah, thanks again for the congratulations as well. We just started the new company, Inferact, with some of my best friends who work on vLLM for a couple of years. And yeah, we just actually moved our office to San Francisco, Market Street.
Oh, great. This is the place to be. Actually, for some context to our audience, so vLLM is the most popular AI inference engine, and I think the goal of the Inferact company is to accelerate the AI progress by making the AI inference cheaper and faster. And today our guest, Woosuk, is actually the co-founder and also CTO of Inferact. So I think Woosuk is definitely probably one of the few people who are at the very frontier of the AI infrastructure. But before diving into that, I actually did some research of your prior experience. So Woosuk, he joined Berkeley in 2021, working with the legendary Ion Stoica. I think at that time, it's still before the wave of language model. It's very different from the time when I started my PhD, which everyone has already been talking about LLM. So what's your first project in your PhD?
Oh yeah, that's a good question. So kind of my first project was Sky Pilot. It's another kind of big, pretty large scale open source project at the time in the lab. And it's something we call intercloud broker. Basically, it's a tool to, because nowadays there are so many clouds, small clouds particularly, small neo GPU clouds. And it's basically a tool to navigate all these different cloud options and also actually launch your job and manage your job through one kind of platform.
Oh, so it's more for cloud computing?
Yeah, it's actually not direct into ML systems, so to speak. It's more at the cloud computing layer. And back then it's our lab's big agenda was something called Sky Computing, which is kind of very relevant to multi-cloud computing. Okay. And this Sky Pilot was one of the premium projects at the lab at the time.
Okay.
Yeah, and it actually helps me. I mean, I kind of joined it quite randomly. I was first year student, and I was kind of trying to figure out. Yeah, kind of in a sense, I was kind of assigned to it, but it actually turns out to be a very good experience for me in the sense that the project was very kind of very practical like compared to other projects in the lab or academia, right? Like it has a real users and it tries to deliver its whole focus was on delivering the best user experience rather than, like coming up with novel ideas or things like that, honestly. And yeah, that helps, so the project focus a lot on the like UI and UX and things like that.
Really?
Yeah, like, the whole focus of the project is like kind of removing the complexities and difficulties in using multiple clouds, right? Because they have so different like options, even like so different CLIs and things like that. So you try to kind of provide a seam layer between all these cloud vendors. So like the project is naturally focused on UI and UX, and also as a part of the project, I talk to a lot of customers, the users, and also potential users as well. So actually, that helped me and like shape my research taste and project taste early on in my PhD.
Oh, that's very cool. So to sum a little bit, like when you just start in 2021, it's more working on this cloud computing kind of infrastructure. But then I think for vLLM, it is released in 2023 in June. Correct me if I'm wrong. So basically, you guys are still very, very early on in the AI infrastructure space. So what triggered the change, like you shifting your focus from cloud computing to working on AI infra?
Oh yeah, that's also a great question. So actually, before I started my PhD, my background was still on like MLSys, more on MLSys. I
What type
work
of
on,
analysis?
kind of like I got a chance to look into like PyTorch internals quite deeply, and also I was pretty familiar with CUDA programming. Kind of like it's also not really intended, but kind of my like undergrad experience was kind of like somehow into it, and yeah, like I was kind of still working on Skypilot at the beginning of my second year in 2022, but like around that time the OPT model from Meta first came out. I'm not sure like how many people remember this model at this point.
I remember at least.
Yeah, but it was kind of first generational like large scale open source model, open source LLMs coming from Meta. Our lab basically had a small project to serve this model, like to freely to the users and try to kind of advertise it in Twitter like back in the day. And yeah, I was kind of somehow also kind of randomly involved in that project. I was kind of assigned a task of like optimizing this like inference, this serving, like because it was so slow, super like resource heavy and things like that. And yeah, that was kind of the beginning of the vLLM project, so to speak.
Oh, just start from that experience, like trying to serve one specific model, but later kind of inspire you to do vLLM, which is trying to serve all sorts of language models at one place.
Yeah, exactly. So at the beginning, I was thinking it's kind of like 1 month short, like simple engineering task to, for my personal learning. But like later on, I realized that it's actually not a like trivial thing to do. And actually, a lot of engineering and like research ideas need to be put into it to get the best efficiency. Uh, yeah, and thankfully, like while we were building this project, ChatGPT came out in like November, December 2022, and a few months later, Llama came out. So it was kind of I was very lucky, honestly. Yeah.
This is also, I think, is really like I think it's a reflection of like the taste or focus, right? Because you guys already think it's important to try to serve that one specific model. Otherwise, you won't even try this so-called like 1 month engineering practice. How can you even imagine like right now vLLM is used by so many people and the project has already been almost 3 years old.
Right.
Yeah, and actually you mentioned for the beginning, like the optimization is still mainly focused on efficiency. And I also remember when I read the vLLM paper, the main technical part is also the page attention. So to give our guests some context, like page attention is trying to just handle the KV cache similar to how operating system is handle virtual memory. So at that time, it's very kind of focusing on efficiency. However, when I'm preparing this podcast and just chat a bit with people around me about vLLM, many people are not directly pointing out efficiency, but they told me that, they are working on using like some other inference frameworks such as deep speed, things like that. But later they locked in vLLM because how clean the user interface is and just how easy to set it up. So I'm wondering, when working on such a large system, what are some desiderata you guys try to think of when designing it?
Oh yeah, that's also a very good question. So yeah, actually, I think we got more users from like this simple UX than like vLLM's performance. Very honestly, like vLLM is actually honestly not the very first inference engine that can run LLMs. There are actually a few preceders like NVIDIA faster transformer. But I was also using it for my research before I was working on vLLM. Yeah. And like unfortunately, it's definitely difficult to set up. Yeah, a lot of I even need to learn CMake to even start building it and to start like using it and things like that. So yeah, we definitely carefully design the user experience, and like it's actually very simple. Like the only thing given that all the model code and model config is kind of like standardized in the Hugging Face format for the popular open source models. Like actually all the information the only information you need from the user is just like a model name. What is the model name? And basically like in the Hugging Face model repo. And without information, you can actually decide everything. The system can decide everything by itself. And that's like kind of the initial like finding when we're building open source. And we kind of try to, like the very initial interface at the release time was kind of just only required this model name, and everything else kind of automatically settled. So yeah, I think that's actually like one of the main power driving the adoption of vLLM early on. And still it is very, like we really care about it.
Yeah, I really remember this carefully because when I started my PhD in 2023, the first project I work on is like a Storm, which is a deep research-like system. But prior to that, so at that time we also got a lot of attention on GitHub, and people are saying, well, can you guys, besides like OpenAI or Cloud API, can you support like self-served language models? And that time I survey a little bit, and the first thing I got to integrate is like vLLM, because it's just very easy to set up, especially at that time there is no coding agent to help me, right? Like some other tools, like I remember even one, besides just this model name, which is easy, I remember for vLLM, basically when you call the generate primitive, it only needs like a string, like a text string. But for many other inference framework at that time, I think because they are more aggressive into optimizing for performance, so they allow you to, they ask you to input tokens. So it's different from inputting string, right? But you can imagine from a system integration perspective, inputting string is just way more convenient. So I'm wondering, like, as system people working on infra, there must be a tendency just to push really hard to efficiency or just optimizing those metrics. But why vLLM kind of choose another slightly different path?
Yeah, I think that's actually kind of relevant to our team's background and also my personal background. I think like our team basically, coming from research lab, so we have very, very high bar on the complexity on the UI side, right? I think like production people, industry people tend to have more tolerance, like on the complexity of a code or complexity of the UI, but researchers tend to kind of know nothing in a sense. Yeah, like so. I think that's one reason, and second reason is basically, I also pushed hard on this UX side because of my previous SkyPilot experience. SkyPilot also has a kind of very, very simple UI and UX. So yeah, I really liked it personally. So I wanted to put that kind of spirit into vLLM as well.
Gotcha. This is actually a great segue to mention a little bit like why we are inviting Woosuk to come to our podcast today, even though our podcast is focusing on technical human-centered AI, right? I think to push the goal of human-centered AI or that AI benefiting more people, it's really like a full stack effort. We need application level breakthrough, we need algorithms like RLHF, but we also need infrastructure to support our vision. And again, even within the infrastructure, how to let the infrastructure to be more accessible, right? Because I remember before vLLM, even just making inference itself, even using the model is super hard, even for people well educated in top research lab. So I think this is the reason why we are inviting Woosuk to here as our guest today. And actually, I think speaking of like a lot of decision choice vLLM is making, I think it's kind of crazy. Like right now, even in the repo, there are over 1,000 issues, over 1,000 pull requests. But how do you guys usually decide like what are some features to prioritize on?
Oh yeah. So very honestly speaking, we're not having a very structured process. Honestly, like like for example, like kind of very well-defined metrics to decide priority or things like that. It's kind of our vibe mostly. I mean, very honestly, yeah. Like, but the thing is, we talk to the users very often. Sometimes we have a regular meeting, like weekly or bi-weekly.
What type of users is?
I mean, basically, like mostly the industry users, like some people in the company, like usually just like like managing their own inference service internally. Like we are talking to this kind of developers pretty often, and we hear their pain points, and yeah, like, and that's basically I think the main, like yeah, the main factor we consider when deciding on making technical decision. And also sometimes like people, I mean, a good part of open source is that some of these users actually implement their feature for their own and then upstream it and basically like tagging us to review it and iterating on it. So yeah, that's also kind of a good way of uh, prioritizing some kind of feature, because sometimes if the PR is coming out and then we know concretely what to do, then we tend to like prioritize it to get it shipped. Yeah, so it's kind of all mixed. Yeah, maybe at this point, I actually thinking we kind of need to improve this decision-making progress. But so far, it's like just by talking to the user.
Next to either community contribution or you directly talk to the user.
Yeah,
so it's
right.
all come from like those people who are actually using it or want to use like vLLM.
Right. We're not like kind of in the spirit of, oh, we implement something we think cool and we think very like useful and novel. I mean, this way of thinking is also sometimes works, but we are kind of more like practical mindset, where we are kind of driven by real user feedback and real user like complaints.
This is actually pretty amazing because I feel I'm not like I didn't did my undergrad just in computer science, so sometimes I view like how CS people work more from an outsider perspective. But one proper trait I found on many people is they just very into optimizing for metric. You can imagine like, oh, if I care about a certain metric, I just think about a novel approach, try to optimize it. But I think the approach you just mentioned is actually quite needed, especially given now AI is not a thing just within a certain lab, right? Like everyone maybe try to use it for their own application. So this, like how to lower the barrier, how to listen to other people's source, I think is getting more and more important. Actually noticed, like I recently looked at the vLLM blog. Actually, I'm an active follower on that. And I saw you guys just released like a blog post called Streaming Requests and Real-Time API in vLLM. So I think this really matches my personal experience because I run a lot of user study, and sometimes I notice compared to pure model intelligence, like how much score they got on MMLU or other benchmark, sometimes real users actually care more about, how smoothly the response can come or how fast the response can come. So I think this streaming feature is like strictly tied to user experience. And in the past, I think all sort of frameworks, they support streaming output, which means even before the model finished generating the whole sequences, the inference server will kind of bring tokens to the user right now. But recently, I think vLLM is supporting streaming request, which is basically when even before the user finishes speaking, the model can start processing. So can you maybe share a bit more about what this feature is and what motivates you guys to try to implement this feature given there are thousands of requests?
Oh yeah, I think this is actually a very good example because this feature, first of all, like kind of came out from Mistral, which is also like one big vLLM user, and they basically implemented a prototype of it and made a PR to our repo.
So they initiated this.
Yeah, actually they initiated it, and also at the same time, like some team at Meta also interested in it, and they also kind of joined this like thread, and with them actually the initial implementation was kind of like not. Yeah, but we basically like the initial implementation was like a little bit of like issues when in integrating vLLM and like keeping it maintainable. So we iterate on it actually like for like maybe like multiple weeks on the design, and we finally merge it and write a blog post about it.
I have a question. When I think about streaming request, I thought the main challenge is in the modeling side, because to explain a bit about like what streaming request means like the model can process chunks, right? Like otherwise it needs to wait for the whole sequence and then process the whole thing. But I feel like this is mainly for the model. It needs to be able to process chunks, so you probably need to retrain or use some smart training algorithm to train your model. But why? It's also a challenge for the inference server.
Oh yeah, so it probably doesn't sound very like intuitive, but it's more like, undermining some fundamental assumptions we make through the entire code base in vLLM. So far this kind of prompt like always come like at once, and like from that it's basically from that we generate certain number of tokens out of it. This kind of simple model, one of the most fundamental assumption we made in the vLLM, and that assumption is embedded in like the whole repo, like with like more than like hundreds of thousands of code.
Oh, that makes sense, right? Because like how it starts is like page attention, right? It assumes like, oh, this kind of have a high hit rate of the KV cache. Otherwise, suppose it's just random access, maybe the original algorithm won't work that well. Is it like this?
Yeah, I mean, yeah, it's partially related to page attention, but it's even without it, it's just like we wanted to make this kind of generation model. I mean, like our mental model as simple as possible, right? And at the beginning, or like until very recently, the streaming input was not like really a thing, at least in the open source world. So we basically didn't really consider in our like basic mental model. And now the challenge is actually, like this kind of new feature undermines this basic assumption. So we kind of need to revisit. Oh, where do we need to? Where do we actually embed this mental model in our code? And if there's some, yeah, like for this kind of code, we kind of need to do some modification.
Gotcha.
Yeah. So it's actually more like, yeah, like how this like software develops, right? Like you start from some assumption, and later on this assumption breaks.
Yeah.
And like even if the assumption basically on the assumption, like it's a very small change actually in the streaming input is pretty small change in this mental model, but still this small change requires a very wide range of changes in the code base, because this assumption was so fundamental to an inference engine. So that was kind of a challenge, but we managed to get it. And the benefit again is that like now that when people like me are speaking, the inference engine can handle and pre-compute what I'm saying, so that immediately after I finish my speak, then the model can generate the output. Model can speak back to me. Yeah, that's kind of like like latency reduction was the whole purpose.
Yeah, exactly. So the reason why like when I read you guys' blog like regularly, but the reason why this caught my eyes is because nowadays for a lot of like human-facing applications beyond this text modality, there are more and more like audio, right? Like for audio, just like how we are talking right now, if like my sentence speak for 1 minute, you don't want the model to start its first token after 1 minute, right? That would be really horrible. Then will be 1 minute and a long period of wait, and then model speak back. But like with this streaming feature, basically the model can start processing even when I'm still talking. And I feel this will get more and more useful, because right now with a lot of agentic application, people are also writing super long prompt, right? Like writing prompt may take 30 minutes, right? Like then suppose we can overlap this user's action with the compute. Then we get a lot of time maybe for free.
Right. We are also thinking of how to expand this feature to diverse use cases. Yeah. Actually, like this, like heavily multi-turn, like agentic cases. Also, we are kind of prototyping one. Actually, we are actually prototyping one approach to it, and yeah, it's not agentic, but also in the conversational case, I think one important thing is whether the model can like interrupt the for example, if whether the model can interrupt me when I was speaking, and sometimes that's kind of like needed in the conversation, right? And that also is something we're looking into. Like, it's kind of difficult to do it because there's no such model in open source space. But like we are trying to, we do need that kind of thing will be happening in the future. So like we are trying to prototyping like how to support this case.
Very cool. I feel there will be soon models like this because even in our first episode, that guest, he is talking about like a mixed initiative system, which means like besides human can initiate questions, the model can sometimes interrupt or even chime in to give some suggestions, right? So I feel many people start to realize, oh, given model sometimes is even better at a lot of things. You cannot just let human to taking initiatives. So I feel maybe they will soon have like a native support from the foundation model side. And it's crazy, like you guys already start prototyping it.
Yeah. I mean, it's also about like assumption, like when the basic mental model of this LLM generation, like if you don't consider this kind of like interruption case, then we kind of need to, when it actually comes up, we again need to revisit all the code and think about like in which place we need some modification. So we're kind of trying to do it more proactively, given that this model hopefully will be coming maybe like this year.
But you mentioned like the word assumption multiple times. I'm just curious, since I also write system like this kind of agentic work myself. How do you guys make assumption at the first place?
I mean, like, how we make assumptions?
Yeah, you just mentioned a lot of design and this all the code base is based on some assumptions, right? Then what's the process for making the assumption?
I think that's a very hard question. I think it's very honestly, it's more like very implicit. Like you have some, when writing code, you must have some kind of mental model of the workload, and
so the workload is more like how developer is calling the engine, or is like how the user is using the model?
I was thinking about like I was more talking about like developers. Yeah, like for developers, say for example, like a sequence. For example, the language model consumes and generates. It's just like, say for example, there's a prompt part and there's output part the model generates. I mean, this kind of mental model is already making an assumption, right? And this assumption doesn't really, cannot really handle the streaming input case, for example, or a very like multi-turn case, for example. Like, so yeah, I'm talking about this kind of assumption. It's not like very well-defined term, but yeah, trying to get the...
More coming from observing like what are some potential applications those developers try to make, and or even like just observing like what these developers try to use your system for. This actually makes a lot of sense because I think sometimes we are tempted to try to develop a system that will suit all the use case, but actually a trick is like if you can identify what's the major use case, it saves tons of challenges, right?
Right. Yeah.
But speaking of this, I also have a question which I personally is curious a lot because this year I think there's another paradigm which is getting more and more popular, which is like a continual learning with reinforcement learning. So again, to give our audience some concept, is like if you think about, for example, Cursor's tab model, they actually do things like this, where they use the user's kind of feedback, or like whether user accept or reject a tab completion to further continually improve their tab model on the job. So in this kind of workload, the reason why it's very relevant to the inference engine is because now the boundary of inference and training suddenly blur, right? Because normally when I think about inference, it's oh, I train a model. Now I just want the checkpoint to be used. Then I use it for inference. But suppose it's like used in reinforcement learning. That means even during the training, you need the example, right? Because this is how the RL algorithm work. And again, for their on-the-job continual learning, it means, oh, the checkpoint also needs to be swapped out for inference because it's, again, serving the user. So like the boundary suddenly, maybe there's no boundary. So wondering like whether this emerging paradigm will also shape how the inference server would be designed.
Oh yeah, that's also another great question. So I really like haven't got a chance to think about this use case very deeply because still not, this is kind of very emerging and very recent thing.
This year or late last year.
Yeah, but like from systems point of view, I think first thing that is really important is the kind of the granularity or frequency of the update, because
you mean the model update?
A model update, because strictly speaking, I mean, like if I want to do this, deploy this kind of continual learning technology to my production service, then what do I do? The first step would be very, very simple. Like I will just collect the rollout and rewards in the inference service, and periodically, maybe like every 2 hour, every 1 hour, or every like 24 hours, I'll send this rollout and reward to the training engine.
It's more like a sync setup, right? Basically, we are kind of, there is still a time like lagging behind for the inference server compared to the current policy being trained.
It's not like necessarily, because during the inference, these weights are fixed, and then like I send this rollout and reward to the training engine, and with the same weight, training engine basically computes updates the weights basically, and then send it back to inference. So this is still own policy, and we just that like we don't like do it in a very frequent manner, and I think this is probably most similar to the cursor case. In the blog post, I think cursor says like it updates the model every 2 hours or something. So I mean, still this is own policy, like kind of continual learning RL, but in this aspect, it's actually not very different from the typical RL setting where the inference and training are pretty still separated. And yeah, the systems perspective, this is not a huge challenge. You just sending the rollout and like updating the weights periodically. I think more challenging thing, I'm not sure, I'm not like expert in continual learning, but like more interesting thing is like if you want to update the model like during the rollout, I think this is kind of
this is what I'm thinking about.
Right? Yeah. In this case, I think it's definitely a more challenging from systems perspective. But this is also, in my point of view, is kind of already happening in RL in some case.
What do you mean?
There are certain like async RL algorithms where you basically, because the RL has a lot of like outlier rollouts, very long rollouts for certain samples, and like some RL algorithms basically like tries to update the weights, while these like outlier rollouts are not finished, yet. So this kind of thing, like in some sense, is already happening, and to my maybe due to my lack of imagination, like I think the future continual learning system would work similarly, I guess. So where basically it's similar to the current RL setup, and maybe there are some certain set of like optimization where you, certain set of like techniques where you can like update the weights in the middle of the rollout, but like from systems perspective, still inference and training are separated.
Got you.
Yeah, and training, which means basically inference sends the rollout, and training recomputes this rollout to get the probabilities and things like that. And these kind of setup like paradigm is pretty solid and pretty efficient from systems perspective, that like I can easily imagine like more like different kind of paradigm, to be honest.
Yeah, I see. Because I think because we are working more like learning from human, this kind of topic, so I actually check like some popular open source frameworks such as like Vero. Like I think this is how they implement basically for their IO. They basically purely separate like inference server and also those training actors. So I think this is what they are currently doing. But I'm wondering like for the more integrated version or like the thing you just say, potentially we may envision a world like this. Would it kind of be different, suppose we are training the full model or if we are just training some like LoRA adapters?
Good question. I think LoRA like basically makes the model weight updates much easier. But other than that, I can't. Maybe due to my lack of imagination, like I don't think the fundamentals change that. That doesn't really change the fundamental. On the training side, because of backpropagation, we need to keep keep all the activations, right, so that we can backprop later on. And this is a huge overhead on the inference side, especially for the autoregressive models.
Exactly.
Yeah, and that's basically the reason why just getting the rollout without any activation from inference engine and just recomputing all these intermediate activation and gradients on the training engine seems to be much more efficient. And I don't, like unless the fundamental algorithm changes, like I think this will remaining the same.
Okay, that's actually a very good take because if we think about it, right, I think for the training part, the more like the most compute heavy part is actually maintaining all those internal state to make sure we can update the model. But by separating the inference, actually this part I don't need to care anymore for my inference server. So potentially this separation is still great because then that kind of heavy part you only need to consider in one side. Otherwise, if it's like too integrated, then probably that part needs to be kind of stored in two parts, which is a bit nasty. But I think it's just very interesting to think about like, all these emerging paradigms or like emerging applications, how they are shaping even this AI inference server, which is like at the very bottom of the infrastructure layer.
Sure. And who knows, maybe there can be some fundamental changes to the architecture or the training paradigm, then that will completely change the story.
Yeah, like you said, it's like changing the assumption this whole vLLM code base is trying to make. And actually, thank you so much for sharing all this more like in the technical perspective. But I'm also curious, is like, right now you are also now a CTO for a new startup. I'm wondering like why you think this shift is really needed for like advancing the goal to make the AI inference like cheaper and faster. Why can't we just stay or in like an open source project?
Oh yeah, that's also a great question. So in my point of view, open source is still just a library. And there's a fundamental limitation of a library, what a library can do.
You mean a difference between library and service?
Yeah, library and service, and also like a company product can do. Yeah, because like like for example, like let's say you have 1,000 GPUs you want to deploy like different types of open source models for. Then just having like even if vLLM does its best job, still there are a whole bunch of challenges that makes these things very complicated, right? Like you need to know how to handle this 1,000 GPUs, and you need to do like automated updates or things like that, and like so things like that. So there are a lot of complexities that I think a library cannot solve inherently. And I think I was thinking this startup by making a company around it, we can basically fill the gap. Like that the developers or users can truly leverage the open source models with kind of almost like zero effort. Yeah, so that's kind of like one motivation. And second motivation, honestly, is it's just like for vLLM itself, because like even though we kind of managed to do like decently well, like
not
doing
just
our PhD.
decently well, it's already crazily well.
But
got
like,
over 70K star already.
Yeah, but still, it's difficult to keep the open source surviving without a company backing it. So just thinking about like CI cost, for example, we are using a lot of GPUs for our CI. We're kind of like almost like reaching the CI cost of like PyTorch organization because we have so many CI, so many tests, and it's actually have been very difficult, have been very challenging to find a company to sponsor it. Thankfully, so far we got sponsored by various companies, like including AWS, but we want something to be more stable, and now we can do it with our own funding. So yeah, like there are certain kind of cases like who will pay our vLLM Slack with like almost like 10K users.
Oh.
Yeah, like it's super
You
expensive.
should share our podcast in this vLLM Slack.
Yeah, sure, I will do. But like, yeah, so even just for the survival of the project, actually, like having a company behind it is the kind of the best way to guarantee this. Yeah.
Actually, I'm pretty curious. Like right now, we also already have a lot of big players in the LLM space where they release commercial APIs, where kind of hide the whole complexity of inference, like the whole inference. They have large team who can like maintain inference. So what do you think? Like suppose setting up like open source inference become really effortless, what would it mean for the ecosystem? Like how will it change like how people build application? Like what do you think about this?
Oh yeah, so I think one advantage of using like open source, like application builders or like model developers, it's kind of like providing a white box, right? Like if you just consider inference as a whole black box, then basically there's certain kind of limitation that you can do on your like model side, on the application side. Yeah, like with this like inference engine being open source, like as long as you have the energy to look into it, you can actually treat it as a white box, and you can basically co-design your application or model on top of it. And streaming request, for example, is a good example of this, right?
Like it's kind of training and inference co-design, right? Because you need to train the model to have the capability. But now you know how it's handled in the inference, so you can tailor the training to take care of this.
Right. Like I think that's a very good example, and also yeah, maybe you can also do it in industry as well. Like for your certain application, you can better optimize and better design the inference workflow with that. Yeah, I think that's kind of the reason why a lot of companies have their own inference team. Like, although you can have like just like off-the-shelf APIs, like these APIs are not usually. I mean, it's useful for many people, but it's not useful for all cases. And for more advanced users, I would say, like usually inference needs to be white box for their usage.
That makes a lot of sense. I think even for nowadays, a lot of commercial API, they kind of have different version of their model, right? And the version is kind of being more and more fine-grained. But still, there are a lot of nuances in the inference, like what's the quantization you use, or even like how much compute you allocate, how they are batched together. They are just all sort of small, tiny things hide behind the API, even though you can specify which version of model or which version of the sampling you are using.
Right. Like I think inference is kind of multi-objective. You want to minimize latency, but you want to maximize throughput so that you can minimize cost. And also, yeah, like some accuracy perspective determines how aggressively you can quantize your model. So like yeah, it's a multi-objective problem. While we are trying to help this kind of users, but it's a pretty complex problem, and for a while this complexity will remain there.
Got you. But I think right now, based on my read, I think Inferact is more targeting to those users who already got like large clusters where they have their own workload, like large scale workload to optimize. Do you see like in a vision, maybe in a few years later, like we'll kind of have models like small, like they can run even in smaller cluster or even just run on local PC? Do you think that kind of inference workload will also happen?
Oh yeah, sure. I think it's, like a lot of people want it, and like if you look at, like Hugging Face or Hacker News, I think people actually care more about this like local models, especially for these hackers. Like I think people really care about like running the model on their own machine. Like yeah, like and also I think probably like just like normal users would definitely prefer it. So I can clearly see it happening. It's just that probably depends on the task you like to perform, right? Like for the tasks that more something like, I don't know, like professional task, I would say that, you know, like a little bit of smartness really matters a lot. Like for maybe software engineering, maybe like medical, like legal service, you know, probably you don't want to use like these like small models.
Yeah, well, especially when you are competing with your competitors, right?
Yeah, sure, sure. But for some more like, you know, more trivial or like low challenging tasks, yeah, I can definitely see it happening. Yeah.
Do you think vLLM will try to support this kind of use case?
I cannot say how, like certainly about future, but right now probably no. Honestly, because it's also a pretty different world.
I think very different assumption, to be honest.
Yeah, very different assumption. Exactly.
Using your word.
Exactly, and yeah, as a startup, for example, we also need to focus. We don't have it in our like recent roadmap, but who knows? Maybe like several years later. Like,
But I think this future, as you mentioned, I think it shows like inference or this AI infra really has a lot of opportunities, right? Not just like different new application, new training paradigm, or just even like people's different workload, or even the potential future where people can run locally some of the models. So I feel like this inference space has a lot of potential to play around, and I think Infract would definitely play a really huge role in it.
yeah, yeah. So definitely, I'm very excited.
Yeah, I think thank you for sharing all this. I just have like one last question. Like I think based on my personal impression, like the whole vLLM team is just so productive and so amazing coders. But right now, we have like a very strong coding agent. Do you think the coding agent can create the vLLM code base from scratch? If going back to, I would say 3 years ago.
Great question. So I'm not super expert in coding agents.
Do
but I
you use
it?
it?
Yeah, I mean, I use it every day, and everyone in our company use it every day. It's so good. I think my current understanding is if there's a one developer who knows about inference engine very well, then I think he can probably like make something like vLLM with many iterations with the coding agent, not just like kind of like one shot from a prompt. Because like this inference engine itself has pretty like actually pretty large volume. You need a lot of components herein, and I believe maybe I'm too naive, but I believe the coding agent is not up to there. But if there's a one developer who are already knowledgeable about the system and what it needs to like look like, then I think with many iteration, he can develop something very nice. But also another challenge actually is that like inference engine, like vLLM itself, it's not only about serving one particular model, right? We need to serve hundreds of models. Yeah, like that's kind of our goal, and I think this also adds a lot of complexity, and probably it'll be hard for AI agent to get it through because it needs more larger context and also much more like much broader testing. Yeah, community driven. So yeah, so the TLDR is one knowledgeable developer with many iteration, I think he can make a decent inference engine for a single model.
This is really a nice answer because sometimes I'm thinking, given all these agents are so good, like how human could potentially collaborate with coding agent, right? I think you actually just lay out a very nice path. I think maybe the coding agent know very well about how inference itself is working technology-wise, but the human is providing like, understanding the needs from the community, understand what workload are doing, or even being able to make those assumptions like what we want to prioritize. This is the part where humans still need to do, even though we have a really, really strong coding agent. And I feel this is actually a really compelling answer of why we still need a human role, even we have a lot of strong AI agents do the actual implementation work. Okay. I really thank Woosuk for his time to come into our podcast today. And to conclude, I really hope this episode could be an opportunity to connect the application community and the infrastructure community. Because as we discussed in the beginning, I think to advance like technical human-centered AI, just let AI to benefit more people, we need the efforts from the full stack to involve different communities towards this goal. Thank you so much.
Yeah, thank you so much.